Good morning, friends. This is Dr. P. Munaswamy, Professor, Department of PC. Today, we are going to discuss about the noise available in the double sideband suppressor carrier. That is noise in DSBSC. So, already last class we discussed about the noise present in the amplitude modulation. So, in case of the amplitude modulation, the signal transmitting from source to destination during the traveling time or within the circuit or that is source and destination, the signal may be affected. So the transmission may be wireless or wireless, whatever it may be. If it is a wireless, so the free space can be acted as a media. So there is a noise or unwanted signal available in this free space that can affect the or wanted signal during the traveling time. So what you have discussed in last class, the noise present in the amplitude modulation. So there we are transmitting the carrier signal, a noise, and also two sidebands, so upper sideband, lower sideband. So whereas coming to the DSBSC wave, double sideband suppressor carrier, so we are suppressing the carrier signal here. So the name itself indicates double sideband suppressor carrier. So we are suppressing the carrier signal and transmitting the only two sidebands, upper sideband as well as the lower sideband. So that here we are analyzing the effect of the noise in double sideband suppressor carrier for this session. So already you know that what you have discussed, signal to noise ratio SNR is the measurement of the which can measure the performance of the receiver. So based on the value of the SNR, if it is high, automatically can say that the receiver has the high performance. So we are going to measure the SNR at three levels. One is input level, another one is the output level, and third one is the channel side. So SNR at the input means SNRI. So it is average power of the modulating signal, average power of the noise at the input. So it is ratio of the average power of modulating signal to the average power of noise at the input side. And this SNR at output side, the average power of the demodulated signal. So average power of the noise at the output side. So here we are going to measure the SNR at the output side. So that is receiver side. So it is ratio of the average power of demodulated signal. So after demodulation, we are going to take the signal out. So that is the demodulated signal to the average power of the noise at the output side. So overall, we are measuring the SNR signal to noise ratio at the output side. So that it is ratio of the average power of the demodulated signal to average power of noise output side. And third one is the channel SNR. So SNRC. So average power of the modulated signal to the average power of noise in the message bandwidth. So overall, during the traveling time, the signal can be transmitted through the wire or wireless. It may be wire or wireless. So we are measuring the SNR at the channel side also. So it is defined as the signal to noise ratio at the channel side is defined as average power of the modulated signal to the average power of noise in the message bandwidth. Then coming to the figure of merit. So here also we are going to take the calculation of the figure of merit for analyzing the noise in the DSBSC wave. So it is a ratio of the SNR out to the SNRI. So it is a ratio of the signal to noise ratio at output side to the signal to noise ratio input side. So overall, the figure of merit of the receiver is also, we are going to take the F equal to SNR at the output side, SNR to channel side. So it is a ratio of the signal to noise ratio at the output to the signal to noise ratio at the channel side. Receivers are coming to the receiver figure of merit. So coming to the noise in DSP. So we are calculating the S of T receiver signal, that is a DSBSC wave, and then signal noise unwanted signal can be added in the during the transmission time. So overall S of T plus N of T is given to the bandpass filter. So once you have the bandpass filter which can design such that which can reject the unwanted signal, that is noise, and allows the only wanted signal which is indicated by V1 of T. Once you have the V1 of T and there is a low loss cost of carrier signal generation. These two are given to the product modulator which can produce the product of the given two inputs, that is V1 of t and C of t. So V of t equal to C of t into V1 of t. So we get the overall this is. So the product of the modulator is output is V2 of t equal to V1 of t into C of t. So after demodulation, we are going to have the filter arrangement of low pass filter, which can allow the only low pass filter, that is modulating signal, which is having low frequency and rejects the high frequency component. Finally, we are going to get the our modulating signal M of t at the receiver side. Then coming to the calculation of the SNR. So we know that DSBSC modulated wave, it is a product of the carrier signal and the modulating signal. So that is S of t equal to AC into cos omega ct is the carrier signal and M of t is the modulating signal. So DSBSC wave, it is a product of the M of t into C of t. So average power of DSBSC modulated wave is given by P of S equal to AC M of t by root 2 whole square. So we'll get the overall power M of t P. So AC square P by 2. So average power of the noise in the message bandwidth PNC is equal to W into N naught. So we know that the DSBSC modulated wave S of t equal to AC M of t cos 2 pi epsilon. Average power of the DSBSC modulated wave PS equal to AC root of whole square A square by Pn naught. So from this, substituting these values in the channel, the SNRC DSBSC wave, average power of the DSBSC modulated wave, average power of the noise in the message bandwidth. So we'll get the SNR channel on DSBSC wave AC square P by 2 omega N naught. So this signal Vn of t nothing but a combination of S of t and N of t. So Vn of t equal to AC M of t cos 2 pi epsilon and considering a noise in phase component Ni of t cos 2 pi epsilon, Nq of t minus Nq of t sin 2 pi epsilon. So by substituting the Vn of t, you will get the AC M of t plus Ni of t overall common, you will get the cos 2 pi epsilon minus Nq of t sin 2 pi epsilon. So by the local oscillator, we have to generate the carrier signal C of t equal to cos 2 pi epsilon. This signal is applied as another input signal to the product modulator. Therefore, the product modulator produces the output, which is the output of V1 of t and C of t. It's the product of these two. So you will get the beta of t nothing but V1 of t and C of t. Substituting the V1 of t and C of t values, you will get the beta of t equal to ACM of t plus Na of t cos 2 pi epsilon minus Nq of t sin 2 pi epsilon into cos 2 epsilon. Succinctly generated carrier signal, this cos 2 pi epsilon. So beta of t equal to this one. Beta of t equal to ACM of t plus Ni of t 1 plus cos 2 pi epsilon cos 4 pi epsilon by 2 minus Nq of t sin 4 pi epsilon by 2. So we can write this one as the trigonometric equation like this. So when the above signal is applied as input to the low pass filter, we will get the output of the low pass filter as D of t equal to ACM of t Ni of t by 2 only. So average power of the demodulated signal is, we will get the value Pm equal to AC M of t whole square by root 2 to root 2. So by taking the squaring operation, this one AC square P by 8. So average power of the noise at the output Pn naught equal to Wn naught by 2. By substituting this value SNR output DSBSC wave, we will get the SNR O output side DSBSC wave AC square P by 8 by omega naught Wn naught by 4. So overall it will be AC square P by 2 omega N naught. So substituting these values in figure of merit, we will get the F equal to SNR out DSBSC by SNR C DSBSC. So figure of AC square P by 2 omega N naught by AC square by P 2 omega N naught. N naught 2 omega N naught will be gets cancelled. So we'll get the only all the 1 AC square by P. So overall F equal to 1. So always you can say that the figure of merit for the DSBSC wave is always 1. In case of the AM signal, it will be less than 1. So whereas coming to the DSBSC wave, it will be unity. So that is noise analysis in the DSBSC wave. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.